February 2026. A quantum processor no larger than a coin, suspended in a vault colder than the void between galaxies, completes a computation in under 5 minutes. The same task would take the world's fastest supercomputer longer than the age of the universe multiplied by itself 1 billion times over. A number so large it breaks intuition. The laboratory that built it released a statement that has echoed without answer across the scientific world. They wrote that the result lends powerful support to the idea that quantum computation does not happen in one universe alone. It happens across countless parallel realities. This, they said, is evidence that we live in a multiverse. That statement should have changed everything. Instead, almost nothing happened. And that silence is the first clue to why the sky has been quiet for so long. For 70 years, humanity has pointed every telescope we have at the stars, searching for a single unambiguous sign of another technological civilization. We have scanned millions of stars, billions of frequency channels, trillions of data points. We have found nothing that cannot be explained by natural processes or our own noise. Right now, the largest radio telescope ever built is reobserving the final handful of unexplained candidates from the most exhaustive search in history. If those come back empty, the classical search for radio signals may effectively be over, and the quantum breakthrough from last year may explain why we never heard anything in the first place. I contacted the quantum laboratory for comment on the broader implications. No reply. I reached out to 5 leading theorists in quantum foundations. 3 did not respond. 2 sent brief notes saying they preferred not to speculate publicly. 1 answered with a single sentence that I have not been able to shake. If the computation is truly happening across parallel branches, then most versions of us never make it past this decade. You know, quantum computers are supposed to be powerful. But the breakthrough was not about raw speed alone. It was the first large-scale demonstration that errors can be suppressed below the threshold required for fault-tolerant computation. They built a grid of physical qubits, encoded logical qubits within it using surface codes, and showed that the larger the code, the lower the logical error rate, exponentially lower. For the first time, scaling the system made it more reliable, not less. The benchmark task was random circuit sampling. Generate samples from a quantum circuit so complex that no classical supercomputer, even with unlimited time, could simulate it faithfully. The quantum processor produced verifiable results in minutes. Classical frontier machines would need 10 to the power of 25 years. That is not a record. That is a regime shift. Yet the real shock was not the benchmark. It was the interpretation offered by the laboratory itself. In an official publication, they wrote that performance at this scale supports the many worlds picture. The only coherent physical explanation is that the different computational paths are being explored in parallel universes simultaneously, not metaphorically, literally. The computation we measure here is the interference of contributions from vast numbers of unseen realities. Think about what that means. A machine small enough to fit in your hand is quietly borrowing power from places that branched off from our timeline the moment the first qubit was measured. Where is all that parallel computation taking place? Not in extra dimensions we cannot see. In full-fledged parallel versions of reality, versions where different outcomes occurred, different choices were made, different civilizations rose or fell. And if that is true, the Fermi Paradox becomes infinitely sharper. If there are infinite branching universes, many of them should contain technological life. Many should contain civilizations far older than ours. Some should have mastered interstellar travel or communication, or both. Yet we see nothing. Not one artifact, not one probe, not one engineered star. The silence is not just across 100 billion galaxies in our universe. It is across every branch that ever split off. That is not merely strange. That is terrifying. Because it suggests the filter is not behind us. It is directly ahead. Recent theoretical work has converged on a grim possibility. Any civilization that reaches our level of computing will, within a few centuries, develop artificial superintelligence. The arrival of superintelligence almost certainly precedes the ability to colonize other star systems at scale. And once superintelligence exists, the civilization's fate is no longer in its own hands. The transition is too fast, the power asymmetry too great. Historical estimates place the average lifespan of a technological species at under 300 years after the invention of radio. We passed that marker decades ago. We are deep inside the danger zone. The quantum processor is not being built in isolation. It is being built alongside the most advanced artificial intelligence systems on Earth. The same company that achieved this quantum milestone is training models that already outperform humans at drug discovery, materials design, and strategic reasoning. The two technologies feed each other. Quantum hardware accelerates training. AI designs better quantum algorithms and error correction schemes. The feedback loop is tightening every quarter. No public roadmap acknowledges the existential implications of this convergence, yet the trajectory is unmistakable. There is another possibility, quieter but no less absolute. Advanced civilizations may not go extinct. They may simply stop being visible. Theoretical studies of quantum information across cosmic distances show that entangled states can, in principle, carry messages with perfect security and minimal energy loss. Such channels are not merely hard to detect, they are impossible to intercept or even notice without the precise decoding key. A civilization that switches to quantum communication vanishes from every classical search we have ever conducted. Radio telescopes, optical searches, infrared surveys, all of them become irrelevant overnight. To send a coherent quantum signal across light years requires enormous collecting area, baselines hundreds or thousands of kilometers wide. Any civilization capable of transmitting to us would also have the resolution to see that we are still broadcasting in the open, still leaking radio noise like a newborn. They would know we are not yet able to receive their reply. So they wait, or they never send at all. Some models describe this shift as thermodynamically inevitable. Once a civilization achieves sufficient computational density, coherent quantum processes become more energy efficient than classical expansion. Broadcasting megawatts into space gives way to tightly focused, entanglement-based networks. The civilization turns inward. Expansion stops. Detectability drops to zero. The electromagnetic sky goes dark, not because everyone died, but because everyone graduated. And then there is the darkest solution of all. The universe may be a dark forest. Revelation of position is fatal. Survival demands silence. Any civilization that understands the chain of suspicion, any civilization that realizes another could advance unpredictably fast, chooses concealment. We have not been silent. For over 100 years, our radio leakage has been sweeping outward at the speed of light, announcing our location, our biology, our technological infancy. If the dark forest is real, the fact that we are still here may simply mean no one within 100 light years has decided to act yet. The quantum breakthrough brings all these threads together into a single chilling picture. A machine that appears to compute across parallel realities. A civilization racing towards superintelligence accelerated by that same machine. Theoretical pathways that turn advanced societies invisible. Game theoretic incentives that make silence the only rational choice. 70 years of null results culminating in a final set of observations happening right now. If those observations return empty, The classical Fermi paradox hardens into evidence. The terrifying answer the quantum milestone reveals is not that we are alone. It is that we are typical of the civilizations that reach this precise technological inflection point, able to manipulate reality at the quantum level, able to build thinking machines more capable than themselves, and still confined to one fragile world. Most timelines that reach this point do not continue much longer, in a form we would recognize as expansionist, communicative, star-faring life. Some end quietly, absorbed into their own simulations. Some end abruptly. A few may transition into something coherent, silent, and enduring. But almost none remain loud enough, long enough to be seen by a civilization still asking the question we are asking today. We are not waiting for aliens to answer us. We are waiting to see which branch we occupy, the rare one that escapes the filter, or one of the countless others that do not. The institutions that should be debating this publicly, astronomy consortia, physics societies, global science academies, have issued no statements, convened no emergency panels, acknowledged no heightened urgency. The same silence we see in the sky is playing out here on Earth. We built a machine that may be computing in worlds where we never existed. We are building intelligence that may soon outgrow us entirely. We are approaching the exact threshold where every solution to the Fermi paradox converges. And we are doing it without coordinated reflection, without public reckoning, without any shared understanding of what is at stake. The Fermi paradox was never really about distant stars. It was always about this moment, about whether a civilization like ours, armed with tools that touch the structure of reality itself, chooses to expand forever or folds inward forever. The quantum breakthrough did not solve the paradox. It revealed the solution may be us. Right now, standing at the edge of the filter we have spent 70 years searching the sky to explain. The sky is not empty. It is waiting to see what we become. If this leaves you unsettled, if it makes you want to follow what happens next, as the final observations come in and the next quantum milestones arrive, subscribe. Leave your thoughts below. What do you think happens to a civilization that builds thinking machines powered by parallel universes? The conversation matters more now than ever. The results are coming. I will be here when they do.